This module is basically a continuation of the if-else statement which we started discussing in the previous module. In the previous one, we had discussed about some of the examples, and in this module as well, we will discuss some more examples, and additionally, we will introduce you to switch function. We will give you the syntax of switch function, and with the help of some example, we will show you how this switch function works. Additionally, some type of function will be given to you, and we will show you how nested if-else statement works here. We will let you know that you can actually incorporate some more conditions when you are using the nested if-else statement. So let's concentrate on the discussion. In this module, we are going to discuss some more examples based on the conditional statement if-else. Also, some discussions will be there based on the switch function. So, let's consider some of the examples using if-else statement, which will actually tell us why this is so important. Now, let's have a look at this problem. Previously, we noted how if-else was used within the for loop. Here, if-else will be used within a function and also a for loop is there. So, it's a bit more complicated. We know how to define a function, so let's start using it here. Here, we are defining the function FAC, which is a function of x, and we are initializing f to be 1. Now, if x is less than 2, we are taking f to be 1, as we know that factorial 1 is 1, and else that if x is more than 2, we are running a for loop for I in 2 to x and taking the f to be the existing value of f into I. And then we are asking to return f. So basically what we are doing is that we are starting with 2 and multiplying each of the values up to x with the product of its previous values, and we are getting the factorial of x. Now since we have the function FAC, which will give us the value of the factorial of the integers, if we write FAC 5, we will have 120, which is 5 factorial, and FAC 8 will give us 40320, which is the factorial of 8. So, the function is working properly. Now, suppose a number is given to you, then how will you tell us whether it is prime or not? We know that primarily, a number is considered to be a prime if it is not divisible by any other numbers other than 1 and itself. Use that logic here. We are naming the function to be is.prime and considering it to be a function of NUM, that is the abbreviation of number. We are using NUM as the abbreviation of number. Firstly, if the number is 2, consider it to be a prime. Here, we are using else if along with if for the first time. This is primarily used if two sets of instructions needs to be given when the if condition does not hold. Now, we are dividing num by any number starting from 2 to num minus 1. In these cases, if the remainder is equal to 0, that is, in case of any number, if it is divisible by any of these numbers, print not prime, and else print prime, because these are not divisible by any of these numbers. So, this is how the is.prime function works. Now, let us check whether our function is working properly or not. Here, if we want to check whether 73101 or even a large number like 987896 is prime or not, we need to put them within the is.prime function, and we will find that the first two are prime but the last one is not a prime number. So now we can claim that our newly constructed function is.prime is working properly. Now here we want to check whether a number is prime or not using if-else command. Here we are defining the function is.prime to be a function of n. Then we are considering the test function consisting of two of the following: n equals 2, or if n is divided by all its previous numbers starting from 2 to n minus 1, then the remainders are not equal to 0. If either of these two happens, then the true value will be prime and otherwise it would be not prime. Like here, if we put 79 inside the is.prime function, then it will tell that it is a prime number, whereas the function will tell us that 80 is not prime. Here we have another way of checking a prime number. Again, is.prime function is defined to be a function of n. In this case, if n equals 12 or the remainder will not equal to 0 if we divide all n with the numbers 12 to the floor of square root of n, then the numbers will be considered to be prime. Like here, the function gives us 67876 to be not prime and 19 to be prime. Here we have another interesting problem. Here we will be given a year and we will need to tell whether it is a leap year or not. Here the year which we would like to check whether it is a leap year or not is 1900. Now consider this program. Here what we are doing is that we are dividing the year by 400 and 400, and we are trying to see whether the remainder is equal to 0 or not. If the remainder will be equal to 0, then we will claim that 1900 is a leap year. Here, since the remainder will not always be 0, if we divide 1900 by 400 and 400, in fact the remainder will be 0 if we divide 1900 by 4 and 100 separately, but it will not be 0 if we divide 1900 by 400. So actually we can claim that 1900 is not a leap year, and R is exactly giving us that thing. Now we are coming towards if-else with type of function. Here the question is, what happens when type of within first bracket if-else is typed in R? The type of function determines the type of storage mode of any object. So it is an internal function of R, and this shows how R stores any object. For example, if we take x to be a sequence of 1, 2 and 3 and y to be pi to the power 0 to 3, then if we type of within first bracket if else and then again with first bracket na, x, y and types equal, then this is a logical one. Again, if we type true in place of na, then this would be an integer, and if we type false in place of true, then that would give us double. Now here comes the idea of nested if-else statement. Actually, we have mentioned the use of it once before, but now we are discussing the structure of this in details. Till now, we have some idea about what nested means. Grossly, it means something encapsulated within some others. Now, let's see how it works here. Have a closer look at this. The structure of this is very similar to that of if-else statement. But the difference is that for if-else, we used to have only one else corresponding to each if. But here, we have something more. Like here, in this structure, it clearly shows that if the test expression 1 is true, then statement 1 holds. Else, if test expression 2 is true, then statement 2 holds. And if test expression 3 is true, we will say that statement 3 holds. Finally, if any of the 3 doesn't hold, then statement 4 holds. So here we are not restricting us within one else corresponding to one if. Instead, we are having a lot more options when the test expression within if is not true. Now let's consider this example. Suppose x, y and z are three vectors containing scores in 100 on maths, English and general knowledge of 10 students respectively, where x, y and z are a set of vectors having length 10. So the question is, suppose the numbers of these students, each corresponding to maths, English and general knowledge are given, then how to tell who will be classified as first, second or third divisioned, or who will be classified as failed. Here are some of the specifications. Here the total marks is 300. And if a student gets less or equal to 40% marks, the student will be classified as failed. Again, if a student gets more than 40% but less or equal to 50%, the student will be classified as third divisioned. In a similar way, if a student gets more than 50% marks but less than 60% of the marks, the student will be classified as second division. And finally, if a student gets more than or equal to 60% marks, the student will be classified as first division, that is, he will be among the best boys of the class. Now let's see how to solve this problem. Here we are assigning null values to the variables tot and par. Now for each of I from 1 to 10, that is for each of the students, we are adding the numbers of the three subjects and storing it in the variable tot. And then we are dividing tot by 300 and multiplying it with 100, and hence we are getting the percentage corresponding to each of the student. So the tot and per are the vectors of length 10, each corresponds to the individuals. Now what we are doing is that we are examining the percentage of each of the students, and if it is less than or equal to 40, we will mark the individual as failed. Else, if par is more than 40 but it is less than or equal to 50, he will be classified as third division. Else, if the percentage is more than 50 but it is less than 60, then we will print second division, and else first division will be printed. So here is the output for each of the students, and the set of 10 outputs is shown here. Now remember, we have already studied some details about the if-else loop. Now look at what the nested if-else statement is. Here we are considering an example. It involves a dataset on math score. The score is coded as good, average and poor. Now we wish to record those characters as 1, 2 and 3. Now let's have a look at this. The objective is to record the characters. Here the syntax of the if-else statement is primarily the same. The only thing is that we are encapsulating another if-else statement within the first one. Here the scores are coded within the SC variable. Now within the if-else statement we are putting the test element, which is SC equals poor. So if it is true, then 3 will be coded. Otherwise, start a new if-else statement and consider the test element as score equals good. If it is so, then the code is 1 and else the code is 2. So what we are writing is that we are writing here if else within first bracket SC equals poor, comma 3, comma if else SC equals good, comma 1 and 2. And here are the outputs. As always, if else usually turns the program much shorter than the one without it. Now there might be a number of styles using which you can write the if-else statement. Like for the first kind, we are using if print and else print separately, but for the next one, we are writing everything within the first bracket after the if statement. From now on, we will discuss about the other kind of conditional statement, namely switch statement. It takes an example and returns a value in a list. The basic syntax is switch within first bracket statement, comma, item 1, comma, item 2, comma, item 3, comma, up to item n. That is, you can include whatever item you want to include here. If the result of the expression is a number, then it returns the item in the list with the same index. Here comes the role of switch function. Primarily, to check multiple cases while writing if-else repeatedly can be cumbersome and inefficient. Switch is the most useful one in those cases. Here the first argument is the testing value and the subsequent arguments may be the result. Finally, the last argument is the default result. So the question is, how does the function work? Switch works in two distinct ways depending whether the first argument evaluates to a character, string or a number. If the value of an expression is not a character string, it is coerced to integer. Here in this example, since 2 is an integer, so here z is equal to 2. But when x is 3.5, which is not an integer, then z is taken to be an integer 3. Here, in this example, we have generated a random sample of size 5 from a standard normal distribution and have stored the values in y. So, here is our output of y. Now, we are using the median function to calculate the median of y. Now, if we define x as the median and write down z with the help of this switch function, we will finally get the median of y when we recall z. So, this is how the switch function works. Here, we are considering some of the examples. Let's look at this. Here, the center function is written in such a way that we can input the data in the form of x and use the function which will be applied to the data in the place of type. Here, as we are storing a random number of size 10 generated from Cauchy distribution in X, and we want to get the median, mean and standard deviation of these. So we are just using the center function and look at what the output is. We are actually having here what we want to have. In the previous example, we used numeric values, but here we are using characters. Here use.switch function is written in such a way that it will give first when 1 is given, second when 2 and other when 5 is given. Now if the first argument is numeric, it occurs positionally to the following arguments. If the numeric argument is greater than the number of subsequent arguments, null is returned. So the control statement plays an important role when we are processing and analyzing our data. If else is used mostly in R programming because of its vectorized nature. The and or operators help us to combine multiple tests. So here are some of the aspects of the conditional statements in R. We will find more of its application once we go ahead with our next modules. This discussion was basically based on the recapitulation of if-else statement and the switch function. After this discussion, we now can calculate the factorial of a number and we can determine whether a number is prime or not from a group of numbers. So we are stopping the discussion here, and from the next module we will be discussing about different grouping functions in R.